Hi guys, let's look at some power supplies because, well, it's kind of fun, yeah? So, 12 volt 5 amp and 12 volt 5 amp. This one doesn't have the jack plug on the end, and there's a reason for that. So, this is the power supply that Julie had on her monitor, HP monitor, that's used with her little NUC computer, okay? And at the weekend, the monitor wouldn't come on. She said she thought the PC was booting up, but the monitor, nothing. And it turned out the power supply was faulty to the monitor. And this one, something rattling in here. Yeah, and power supplies are something rattling and they're always fun. Now, I've repaired this at some time because it's glued together. That's me, so at some point I've fixed this, I guess, or done something with it. I came into the office and had a look around and I found another 5 amp one. This one has a different end on. So I basically took the connector off here. I could have put it on this one. This was in my box of 12 volt power supplies, and when I pulled it in, it was dead. Okay. And then I found a 3.3 amp one that was working. So I took the end from here, put it onto the 3.3 amp. And that's working. So she actually has a monitor working. That was Saturday, it's now Monday, so it seems okay. But, well, power supplies with something rattling inside are definitely interesting. Let's have a look at these then. So we'll open these up, let's see if we can figure out why they don't work. If it's something fairly simple, I'll fix them, I think. Always useful to have these things. I know they don't cost very much, but these are great for learning to repair. You may find similar power supplies embedded on big PCBs basically, which you need to repair. Okay, so the one that was rattling, let's have a look at this one. I know it doesn't go bang, or it's previously gone bang when there was nobody around. There's no voltage coming out of this, so that's what's wrong with it. I won't show you guys, I'm sure you can take my word for that. So let's have a look inside here. And let's see how easy this is to open up again. Well, it's fairly easy, okay, so crack. It's opened. Okay. That's the power supply. Now, I know I've worked on this before. I'm not sure what I did, why it has been opened. Let's see if we can see anything. Well, there's a bit of soldering around here. Maybe this is me doing something. So what do we have? Well, this is your mains coming in. Bridge rectifier. This looks like a filter, inductor and capacitor. Large electrolytical bulk capacitor. MOSFET, I am guessing. Resistor down there. Possibly a fuse, that one. And some sort of controller chip, okay? 1207 it says on it. 1207A. I may have changed this before. I honestly don't remember what I did with this. She's been using it for a few years actually. Maybe even before I had this channel. No, after that I would say, but I'm not sure at what point she was using this. So that's the controller chip. Nothing looks blown up particularly. And then this is the opto isolator and the capacitor there, which we see between the ground, which is safety ground, and the ground, which is hot ground. Okay, this is to provide a high frequency path for switching noise back to the mains ground. It's a bit strange because here we don't actually have ground on our mains. The mains plugs are not polarized in any way. It looks like it's not even soldered actually. Okay, it looks like that isn't even soldered in there, but for whatever reason they decided to fit that anyway. And then we have the switching transformer. This will be TL431, so this will be the voltage reference. And we have some bad capacitors here, so these caps have failed. Bad capacitors. So they need changing, and while we're at it, let's have a quick look around this with a multimeter and see if we can see any other obvious problems. That is a resistor, by the way, not a fuse. I can see the markings on it now. Okay, so that's what we have, and this looks like it could just be bad capacitors. This is the rectifier diode on the output, you can see, smoothing inductor, and another resistor there, which is probably just to ensure that there's always a load on the power supply even when there's nothing attached to it. Okay, fuse, by the way, and thermistor. Okay, so let's unsolder these. So I think we can say this has failed. Looks like it's failed to me. I've not replaced these before. I don't have this type of capacitor. So 1000 microfarad. I guess probably 16 volt. Yeah, 16 volt. 1016. The other one, not quite so bad, but this is definitely failed. So again, 1016 volts. So we need to change those. The black is the negative. I noticed when I took them out which way round they go. This is also ground, or your negative output to your load, whatever you're driving, and that should go, yeah, look, you see from there to ground. So we know this is the ground end where the black marking is. You can't always trust the markings, by the way. I find this a lot on computer motherboards where you have a white marking, and sometimes that's plus and sometimes it's ground. Yeah. Okay. At least they're consistent here, so we can see the negative end of the large capacitor. It also has the black marking there. So we need to replace those. I have some, but let's just check for any other problems on this. So seeing as we have a problem with these capacitors, we can check this diode. This is the rectifier diode. This resistor looks like 100, 10 ohm. That will put a load on this. I'm pretty sure that's there as a load, although it's quite a low value. Okay, let's see. In actual fact, that wouldn't make sense. That is a load because 10 ohms, 12 volts, 1.2 amps. 1.2 amps times 12 volts is lots of watts. Yeah, so that would be dissipating over 10 watts, and it's not a 10 watt resistor. What value is that? Let's see. This is just out of interest rather than sake of repair. Yeah, it does read 10 ohms, however it's connected it is a 10 ohm resistor. It reads what it says. I'm fine with it, whatever it's doing. So I'm on diode test mode. This is the rectifier diode. You can see it's actually, although there's 3 pins, these 2 pins are connected together. Okay, and we can test from there to the other pin, this 3rd one. Does it conduct with the positive here? Yeah, so that is like a Schottky diode. That's what you would expect. Obviously, it will read the same here as well because these are connected together. So that reads okay. And on the other side of this, well, we should check to make sure there's no voltage in the large capacitor. I mean, this is not being connected to the mains since Saturday, or yeah, but I think it was Saturday I disconnected this, but we can be sure. Safety first. So here is the large capacitor. The legs are here. Okay. Any voltage in it? Well, you see 3 volts. Yeah, can you see that? 2.9. So not enough to give you a shock or anything, but it does show that it will, even after several days, hold some voltage. That might mess up with the readings, so I'll just short that out. I don't need to discharge it because it's almost discharged anyway. 0.3, 0.03 even, yeah, 0.0 something. So let's have a look on this side. We have power coming in that will go via the fuse here. So you can see power fuse. Other side of the fuse will go to the thermistor, probably be tens of ohms, and then that will go to the bridge rectifier somewhere, you would think. So let's have a look from the power end to the fuse. Okay, through the fuse. Okay, through the thermistor. Yeah, 6 ohms, fine. I can see that's where that goes to. This then goes off up in this direction. The bridge rectifier is there, so it doesn't go directly to the bridge, but it must go to the bridge. Oh, you see here, this is this filter inductor, filtering capacitor. So I'm sure we will find that actually just goes up there. We can see it goes there through the inductor here. It ends up on the bridge rectifier, one of the AC inputs, so that's fine. And the other AC input on here will go, let's see, where does it go to? It needs to go to here. And it doesn't. The meter's fine, so the other AC input doesn't go back to here. Okay. So where does it go? Well, it goes to here. That is interesting. That's a diode. I think this is actually just feeding some power into this. This is probably to do with the startup circuit of that thing, actually. So from here then, yeah, it goes to there, which is this end of the coil, and this goes to there. Oh, it does go back to there. It was just reading, the meter wasn't working well for some reason. Try again, on ohms range. Yeah, that goes back to there. So it goes to the diode, and it goes to here. This diode will be giving like a rectified pulsed DC, halfway rectified, probably to do with the startup for this chip, I'm guessing. So all that path is there. That means we should have DC getting into our big capacitor. We can just check the bridge rectifier while we're here, just for the fun of it. So go to one of the AC terminals. Yeah, diode, and then black on one of the AC, other end, diode. Okay, so that's fine. And do we have a short across the large capacitor? Well, we know we don't, because there was some voltage in it. Yeah. So we know we don't have a short there. If we don't have a short across that, it means the main switching transistor is okay, or if that's short, then this resistor here is open. We can have a quick look. So the transistor is here. Probably a MOSFET. That reads like a diode. That reads like a diode. Okay. Maybe a transistor. Although the transistor, this would be the base if it is here. So I don't think it is a transistor. Let's have a look. Yeah, that doesn't look like a transistor. I'd expect this to be a MOSFET. Yeah. So what I think I'm seeing here is a parasitic diode from here to here, in one direction. But I'm not sure why I'm seeing the diode there, but we're not going to worry about it. There's some more diodes here, okay? If they look okay. Let's see. Yeah, that looks like a Schottky actually. That looks like a diode. Okay, so something a bit strange around here, guys. What do we have? Okay, see this one has a 150 ohm resistor across the diode. Can you see it? Yeah, that's across the diode. This resistor is not across this diode. And that means that this one is going to read low because of the resistor. Yeah, 117. That's the resistor. That reads like a diode. So you can't test that one without removing the resistor first or removing the diode and testing it. But I have no reason to really suspect that it's faulty. It's certainly not short. Okay, so that was a quick look around. I mean, there still could be something wrong with the chip or with this. But let's put new capacitors in and let's see if it works. Okay, here we go. Low ESR. 1016. I get these from AliExpress. I buy a lot of different values of these. I've been using these for several years now. They don't come back, so that tells me these are just fine. That one, I'm actually not totally happy with the look of that one. This is a new capacitor. Just not totally happy with that one. Oh, and this one is a 6.3, so good job I noticed. Here's another 1016. That looks okay. This is a brand new one, which actually looks a little bit bulged. Very strange. I've not had any problems with these before, but I'll fit a different one. Yeah, that looks nice and flat. So 1016. 1016. Right. That would have been fun, because one of those would have blown up. Sorry guys about that. You missed the drama. I spotted it. Okay. I have the current limiter up there. So this wasn't doing anything drastic before, but if you've worked on something like this, then play safe. Yeah. So we'll just switch this on. We can just watch the light bulb. Yeah, on and went off. That's a good sign. So just switch it on. And I don't have anything coming out of it. Okay, so it powers up but doesn't work. At least there's voltage gone into the large capacitor, but it doesn't work. Okay, we can just check that. I'm sure there will be a high voltage in that now. Dangerous. Okay, let's see. What do we have here? 309 volts. So that's charged up. That's why the bulb flashed. That's why we should use that thing. Another good reason, so we can see what's actually happening. Okay, so I need to discharge that. And I'll use my capacitor discharger to do this. So just put this across the capacitor. Yeah, see, voltage gone down, 2 volts. Just wait a second. It'll probably come back up a little bit actually. Nothing much. Okay, so that's discharged. That's safe now. Let's see why this doesn't work. Well, we were seeing some slightly strange readings around this transistor, so we can take that out and have a look. We can find a data sheet for the controller chip. There's 2 resistors here which are probably low value, but we can have a look to see what they read as well, see if they give us any clue. So yeah, one of them is here. That reads fairly high, but this could be in the snubber network, which basically handles back EMF. So without having a closer look, and it reads 47k, which is like a standard value, so it's probably okay. The other one is just below the transistor. I think it's from here to here. Let's have a look. And that I just get there's something charging somewhere or something happening. Can't get a particular reading from that one. Okay, so let's get the transistor out and then let's see if we can be certain where that one is and see what it says, and we can test this at the same time. Okay, so I've unsoldered that. Let's see, is it any good? Yes, it's fine. So the MOSFET is actually fine. The problem is, and this is a problem, when I try to undo the screw there, which I did, but you see what happened. Yeah, so I wouldn't trust that capacitor, to be quite honest. I would not trust that capacitor. Oh, the capacitor is discharged, Detlef, my friend, but I wouldn't trust it. Yeah, you see what's happened? It kind of like crushed the case a little bit there, so that could have done something internally, could cause this to go short. Let's see if we have another one, 450, 120, or something similar. I have a 420, 150. That should be fine, to be quite honest. There's no PFC on this, so it doesn't go like to a very high voltage. I know this is a bit lower than that one, but I think that'll be fine. One way to find out, yeah. That's a 150, 450. But that one I think is too big to fit in there. I think this one will fit. I could extend these wires a little bit of heat shrink on them. So, because I know there's no more than about 320 volts DC in this anyway, there's no PFC in this circuit, I'm quite happy to replace that with that one. Just check something else. Yeah, it's also 105 centigrade as well. So let's put this in here, but we still haven't found out what the problem is yet. We need to look at these resistors here to see what they actually are. Well, that's an inductor, L. There is another capacitor down there, you can see. Okay. This has an orange stripe and it's towards the middle of the resistor, so that probably means it's in the tens of kilo ohms. I think this is the one that read 47k anyway. Yeah, that's the one. And the other resistor we can see now. So again, this is orange. I can't read the value, but the one stripe I can see is silver. So silver means times 0.01. So whatever the two numbers are, which would be a 2 digits. So let's say they were 22 times 0.1 would be 2.2 times 0.01 would be 0.22. So the silver is a very low value. 0.1, by the way, would be gold there. That's the tolerance, 5%. So we know this should read a very low value, certainly less than 1 ohm. And we can see the resistor is from here to, well, underneath it. And if you look, actually, we can see this now, that this is one of the terminals of the MOSFET. Goes to the resistor, and through the resistor to here, and this comes to here. And this is the negative end of the very large capacitor, so hot ground. So that is going from the MOSFET to hot ground. That means this is a current sense resistor, and that also tells us it would be a very low value. Okay, so this is going to be less than 1 ohm. Let's have a look. Well, it reads 1.3, but my meter is not zeroing. Let's go to the low ohms range. And now we can actually hit calibrate. 0, okay. What does that resistor read now? 0.2. Yeah, it probably is a 0.22 in actual fact. Kind of good guess, because that's not an unusual value for a current sense. So we know that's okay. We know the MOSFET's okay. We know from the other main terminal, it's probably drain and source. That'd be source, I think. This is drain. This should find its way back to the positive side of the large capacitor, which it does. So we know we have power getting to that. That's okay. So that has been driven by this chip, and this is probably where we have a problem. Either it's not getting the power to start up, or it is getting power to start up but it doesn't run. There could also be a problem with a resistor that drives the MOSFET. So you can see here, there's a resistor, 470 ohm is a sensible value. That goes back to this chip here by the looks of it. So resistor, we'll just test it. So this looks like the gate drive. Yeah, reads 470 ohm. And that goes to here. So we know the resistor for the gate drive's okay. So if this is oscillating, that should run. Let's see what the datasheet says. So 1207A. Here's our datasheet. So this is the NCP 1207A. It's a bit of a strange one in a way, because this looks like the auxiliary winding on the transformer. So this is your primary, switches via the MOSFET and current sense resistor to ground. This will be the current sense input on 3. Okay. Normally you would have a diode in here and an electrolytic capacitor, and this would be VCC. But in this case, that isn't the case. There's a capacitor there on pin 6, okay? And if we look, pin 1, DMAG, core reset detection and over voltage protection. So auxiliary flyback signal ensures discontinuous operation, offers a fixed over voltage detection level, 7.2. So that's actually over voltage detection, okay? This capacitor on pin 6, so 6 is VCC, supplies the IC. This pin connected to an external capacitor, typically 10 microfarads. So we can have a look to see if that capacitor is okay. We have a resistor here, so this is normally how you would expect the power supply to the IC to start it. This would normally be a startup supply, not continuous, saying please refer to the application information section. So a little star by that. And this talks about dynamic self-supply. So DSS, based on the charge discharge of the VCC bulk capacitor. That's the one on pin 6 to ground. Okay, so various conditions cause various things to happen. Okay. I don't find the specific information about the resistor, but I think that resistor is the 47K resistor we can see. We can check that. So from pin 8 to the positive end of the large capacitor, what do we see? Well, this is the capacitor here. Okay, so pin 8. That actually reads open. Okay, interesting. You would expect, according to that typical application, to see some resistance there, which is here, and I'm seeing open. I'll just make sure I'm on the right end of the capacitor. Yeah, this is the positive end here, so I'm in the right place. This is definitely pin 8 here. Meters working, mega ohms range, and I see nothing. Okay. Well, maybe not okay, actually. Not what I expected at all. I think there might be something underneath here that I can't see. I need to take this out anyway, so let's get this off the board and let's have a closer look. I've solved that mystery why I don't see any connection from here to here, and that's because it's not connected that way. And in fact, there's another example in here. Yeah, we see here, so from one of the AC inputs via a resistor, via a diode to there, says this reduces the average voltage on pin 8. Okay. And if we look at ours, that's exactly how it's connected up. So there isn't something under that capacitor, I thought. There is a diode here, which I could see anyway. If you look at the diode, we have diode junction. Okay, that's fine. One end of the diode goes to one of the AC terminals on the bridge rectifier, and the other one here goes to a 4.7K resistor. We can see it marked there, 472, which reads 4.7K. And from this end, goes to pin 8. Okay, so that's how the chip gets power to run. And the other thing that has to be okay is the capacitor, which is there. So let's take that capacitor out as well and see what that's like. Okay, so the capacitor is 25 volt, 47 microfarads. Let's check it. Yeah, that reads fine. This is not a high frequency circuit. You can see it's in fact mains frequency. So this is not a low ESR capacitor. That's not relevant in this case. So really there's nothing on this side now that we haven't tested, to be honest. I've put this back together. I mean, this is a very simple device, you can see. So we know we have a working diode here from the AC input through the resistor into the pin 8 of the IC. So that circuit is correct. I've changed the capacitor there, you can see. Just need to clean the flux off it. I've changed the large capacitor. I've put a bit of tape over this end. I just don't want the metal can touching the metal work here, although it probably is insulated from anything really electrically, but that's in there, so I had to just extend some legs on that one. We know it's a slightly lower voltage, but this won't get more than 320 volts in it, so it really isn't going to be a problem, he says. So we know the MOSFET's also okay, current sense resistor's okay, everything seems to be okay, it just doesn't start. What we do know is that this capacitor charges up to 320 volts and doesn't discharge by itself, which means that nothing's drawing any current, which tells me straight away that this isn't running. If this was running, then it would drain the capacitor when we switch off, and it doesn't. We know there's no shorts on the output. This basically looks okay. I didn't look around this lot here, to be quite honest. Looks like somebody's done some work there. It could be me because I know I've repaired this before. Okay. So we have resistors. We know that one's okay because we basically was reading this across the diode. We can measure these other resistors here as well. And if they all check okay, and this, they are two 1 meg resistors in series, 2 meg. This is why they cross the inputs basically. Mains input. AC, okay, so we don't need to worry about those not doing anything particularly relevant to what we have. So we'll check the other resistors. If they all look okay, I'm going to power this up and let's measure the voltage on pin 8 here. But everything's pointing at the moment to being a faulty IC on the basis that, well, we've proved it isn't any of the other possibilities, okay? And often that's a way to do this sort of repair. So eliminate a lot of things, and then what you're left with, well, the fault must be there. Yeah, we see the multimeter, so 470 ohms, 4710. 470, okay. 4.7k, 47 and 2 zeros. 4.7k. 33k, so 33 and 3 zeros, 33,000. That reads 15, but that's okay. I mean, resistors in circuits will often read lower than the value because of other components in here, but they should never read higher than the value, no matter what's connected around them. This one says 29 ohms. What value is that thing? Yeah, 270. That's not 270. Make sure you learn all these. That is 27 and 0 zeros, okay? 27 ohms, that's reading about right. This one, 150 ohms. 150 ohms. It reads 151, but it isn't 151, it's 15 and 10. Another 4.7k. 3.8, 3.9, that is fine, guys. And we have a capacitor here, which I don't know the value of the capacitor, but I can tell you there shouldn't be a short circuit here. Okay, there isn't a short circuit there. So They read okay. We know we can't read this diode and circuit, but we know why. I haven't solved it in the MOSFET, so I better do that now. There we go. So we'll power this up. We'll have a look at the voltage on this pin, see what the datasheet says about what we should expect there, okay? So I have the light bulb up in the corner behind that monitor. It's there, okay. Let's just switch on and see what happens. Well, it comes on and goes off, so we know the capacitor is going to be charged up once again, okay. That's this large capacitor here now holding a dangerous voltage, 277, going down slightly. Pin 8, what's on here? Let's have a look. Well, that won't have anything on because that's powered via the diode and that 4.7k resistor to there. So I need to measure this voltage while it is actually powered on. So let's power it up again. Okay, what's the voltage? And it's 103, 101, okay. That suggests to me that chip is actually open circuit. Let's see what the datasheet says about that. And obviously as well, let's discharge this nasty capacitor, because otherwise you will forget and then you will try to pick it up, okay. So let's just make this safe. There. Okay, safe, fine. Right, unplugged from the mains as well. It was switched off, by the way, when I did that. Well, you know, guys, just reminding me, because this is a day after yesterday when I started this video. This here should have a high voltage on this on pin 8 to start up, because it's fed via the diode, as we see in this example. And what we really need to do is check the voltage on the capacitor, which is on pin 6. This is VCC. Okay. VCC pin 6 connected to a capacitor, which we know. And I've also replaced that capacitor. And did you just notice, I'm sure you did, that the voltage on the large capacitor, the dangerous one, was actually dropping down. And I'm wondering now if this power supply is actually working since I changed that capacitor. And the reason it's not drawing much power is because there's no load connected to the power supply. Let's check that out. So we have no load, obviously. Yeah. There is an LED down there. Let's just power this up again and see if that actually lights up. I'll just put this on a piece of card. I don't like high voltage stuff on my ESD mat, although in honesty it's never caused a problem. Just me, yeah. So let's just switch this on again. Well, the light bulb came on and went out again. I'll disconnect that actually so it just powers up directly. No, the LED isn't lit up. Let's just check for any voltage coming out of here. Okay. Switch it on. It's on. Do we have anything here? No, we don't. Switch it off. Let's discharge this capacitor again. Or in fact, maybe just leave it because I want to look on pin 6. I want to see what's going on pin 6 on that IC. Well, we can see pin 6 is here. This is the capacitor. That's where we want to check. The other end of the capacitor, well, that must go to hot ground, which is here. Okay, let's see what we have. So we're going to power up again. What's on pin 6? What's on the capacitor? Well, there's nothing there. Okay, there's basically nothing there. So this chip is not feeding any power from that high voltage pin into the capacitor. It's not charging the capacitor. So really that tells us either there's a problem with the capacitor or a problem with the chip. And we've changed the capacitor. I tested this one before I put it in. It was okay. So That brings us down to the chip, and now it's time with this one to order another chip. Back to the large capacitor. What do we have in it now? Let's see. Yeah, 320 volts. Yeah, so once more we need to make that safe. Yeah, they're real cheap. I can get 10 of them for $2.89 with free shipping. Yeah, we can get those easily and cheap. I'll order a pack of those, actually 10, useful to have. Probably come across these things again. Okay, so this one is on one side. Let's have a look at the other one. So this one's not been opened before like that previous one. I need to get into this. There's various ways. Some people say warm them up and such like. I usually find the best thing to do is take a large screwdriver and a hammer and hit one corner, and it normally just splits open without damaging anything else really. So I'm not going to go for the corner right by the power in. I could go for this corner. I could go for this one, okay. A bit of sod's law this, like you're going to pick one and hit something when you should have picked the other one. I'll go for this one because there's probably a lot of capacitors and things around here and perhaps not so much around here. Let's see, yeah. So I'm going to go for this corner. You guys get down there and say, Rich, you should have gone for the other one, yeah. We'll say, Rich, you were right, okay. Timestamp. My hammer is in my van, so let's misuse this thing. Ready? So it's directly on the corner of it and hit it. There. And often that is enough. Look, you see. Just that one knock on there. And it will open now. Yeah, you can see this is open now. So probably need a spudger or something just to complete the job. Okay. I went the right corner, I think. Look at the stuff here. I think I went the right corner. So, yeah. So here there was just a piece of metal. Actually, look, it wouldn't have made any difference. Yeah. So another power supply doesn't work. Let's have a look at this one. First impressions then, similar to the other one. This is a 400 volt capacitor loop. Just made the point I was making about not being that critical if you know what the maximum voltage is. Capacitors look good on this one. These, well, this is the low voltage side, so rectifier diode and maybe a voltage regulator on this one. This is the high voltage side, so fuse I can see. An interesting wire across here. Down there I can see the opto isolator. Much like that other one. There is a controller chip, different chip but the same sort of thing. Some resistance stuff around here. Okay. High value 2 meg resistors across where the power comes in. This is similar to that other one. Something behind here. Bridge rectifier. Can you see it just down there? I can see the corner. So the chamfered end is the positive end of the bridge. Yeah, 4 pins. Bridge rectifier, large capacitor. There's also a NTC thermistor down there to limit the inrush current. Okay, filter. I'm guessing that's probably the switching MOSFET. It's by the transformer. Yeah, 3 pins, you can see it, so a MOSFET there. Okay, secondary side. This looks like it's got a pair of diodes in parallel actually, or 2 double diodes in parallel. Do you see them? So this center pin being the output, and then the other one's connecting to the winding, and all, yes, all in parallel. Look, okay, so not a voltage regulator, just 2 diodes. Okay, that's what we have. Right, so diagnosis. First thing, connect it to the light bulb. Let's see what it does. Let's see if any power gets into the thing. The current limiting light bulb is so useful, not just as a safety device to stop things blowing fuses and going bang, but because it gives us a very good indication of what's actually happening. So watch the bulb. Okay, same sort of thing as the previous one. So power's gone into it. The light bulb went out. Okay. Is the large capacitor still holding the voltage? Well, an easy place to measure as well as on the capacitor is just directly across the bridge rectifier, which we know is here. And the voltage on this one is dropping away. Yeah, there isn't much voltage there. So it's obviously discharging the capacitor. So something is running on this one. Something is live. Yeah, something's alive. This may even be working, but we're just getting no output for some reason. Okay. I'll just check on the output of this one again to be sure. It looks like this one might actually be working. Well, that's interesting because this one was not working when I previously tried it. Now it is working. Yeah, that should go away in a moment. There's no load on it obviously, so nothing particular to discharge that. Let's get a load. Okay, so this is a 12 volt light bulb. Couple of wires tagged onto it. Yeah, 12 volts, 21 watts. So if it was 24 watts, that'd be 2 amps. So it's going to draw about 1.8 amps or something. I mean, you could do the maths, yeah. But somewhere less than 2 amps. So let's try this as a load. I've tagged a little jack socket onto this, so let's see what it does. Wow! It's flashing on and off, but did you notice so is the current limiter? Yeah. Let's try it without it. There you go. So that power supply actually works. Then that shows you how useful that current limiter is. I don't know why this one didn't work when I tried it before, but hey, it's working now. Okay, so I hope you enjoyed that, guys. One of the two is working. The other one, I think we are confident enough of what the problem is. Let me know down there in the comments below, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.